Radicals with fractions. So we just talked about this multiplication with radicals rule, which is that if you have the square root of a times b, that's the same as the square root of a times the square root of b. So fractions work the same way because really fractions or division is just multiplication by a reciprocal. So whatever applies to fractions, or sorry, to multiplication, it must apply to fractions as well. So there is this same rule for if you have the radical of a fraction, you can just do the radical of the numerator and denominator individually. And that'll help us simplify our fractions. So let's take a look at an example. If we want to simplify this radical, rather than looking at this complicated radical, this fraction and thinking what are three numbers that would give me this fraction, we'll just split it so that we look at the radical of the top and the radical of the bottom. And now our lives are a lot easier. So the cubed root of 16, well, I'll have to do 8 times 2. And the cubed root of 54 is 27 times 2. So that would be the cubed root of 8 times 2. That would be the cubed root of 8 is 2 times the cubed root of 2 is left over. And the cubed root of 27 is 3. And I have the cubed root of the cubed root of 2 left over in the denominator. And now we can actually see that there's going to be a cancellation that happens. We have the cubed root of 2 on the top and bottom. So those two numbers are identical and they cancel, leaving me with 2/3. My life actually would have been a lot easier if I had done what we always tell you to do first. Math teachers always tell you to do first, which is to actually simplify. So before I had gone and taken the cubed root of anything, if I had just taken a moment to simplify this fraction, I would have seen that 16 and 54 have a factor of 2. So divide top and bottom by 2, and I'd be left with 8 over 27. And we could have jumped to the final answer quicker and easier if I had just done that. So from now on, let's listen to the advice of math teachers, and to simplify radicals with fractions, first simplify the fraction, then pull out any perfect squares, cubes, etc. from the numerator and the denominator. So let's see this in action. So we have the square root of this fraction. And I'm looking at 27 and 196, and I'm trying to see if they have any numbers in common. And it turns out they don't. There's no common factor between the two. There's no way to simplify that fraction. And I tried that by dividing by 196 by different factors of 27. So I went 196 divided by 9. Doesn't work. 196 divided by, let's go with 3. Doesn't work. So you can try different factors of 27, but either way, this fraction doesn't simplify. So that's good. Now, once we do that, we can split apart our denominator and numerator and go ahead and start simplifying. So the square root of 27 is not a perfect square, but I could write it as 9 times 3. And m to the 3 would be m squared times m. And in the denominator, the square root of 196 is actually just 14. 196 is a perfect square. So now on top I have the square root of 9m squared. That will that is something I can take a perfect square of, and I'm left with 3m. That's going to be my leftover in the radical, and 14 in the denominator. So the square root of 9m squared would just be 3m, and then square root of 3m over 14. So there is my simplified fraction. So in this example, we have this big cubic fraction, this big cube root with this fraction that looks kind of intimidating, but clearly there's going to be some good canceling that can happen right away. So looking at the top and bottom, x squared is going to cancel with x to the power 5 and leave me with x to the power 3. Y squared is going to cancel with part of that y to the 7 and leave me with y to the power 5. And the fraction, I can do the same thing. I can divide 16 and 54 each by 2, which would leave me with 8 over 27. And then on the top of the fraction, I have x cubed y to the 5th. So you simplify that fraction and then split apart the radical, and our lives are going to be a lot easier than if we just went ahead and tried to deal with the radical right away. So cubed root of, well, 8's already a perfect cube. X cubed is a perfect cube, and then y, I will have to split apart into y cubed times y squared, all of which is over the cubed root of 27, and that's a perfect cube, so that's just 3. So now I have the cubed root of 8x cubed, y cubed, and I'm left over with the cubed root of y squared. So cubed root of 8 is 2, cubed root of x cubed and y cubed is just xy, times the cubed root of y squared, all of which is over 3. And there we go. That's my simplified fraction. So far we've had the radical of a fraction, but we can also have the opposite, which is that if we have a fraction with the radicals that are split apart, we can actually combine them using the opposite of the rule. So if we have a square root of something on top of a fraction and the square root of something on the bottom, that's the same as having the square root of the fraction all together. And what this lets us do is, if there wasn't any simplification we could do before, we can certainly do it now, because 48 can be divided by 3, which leaves me with 16. And a to the 7 over a is just a to the 6. And now I just have the square root of 16 a to the 6, and the square root of 16 is 4, and the square root of a to the 6 is a cubed. So I want to take a moment, because as we're getting more and more comfortable with this, I'm doing these at a quicker pace. If you're still uncomfortable with the square root of a to the 6, what I really want you to think about is that when you're taking this a to the 6, when you're taking the root of a to the 6, what you're always doing is saying, well, I'm canceling a power of 2 with the radical. And so when you're pulling out a to the 6, what you're really doing is it's almost like you're dividing 6 by 2 to get the power that will be left over, which is a cubed. So as you're getting through some of these examples, hopefully you're starting to build up a bit of a sense of how to speed up the process of this problem. So that's the kind of math that I'm doing in my head as I'm taking the square root of a to the 6. So again, if we are to combine these two fractions and then cancel, it's going to make our lives a lot easier. So the cubed root of, well, 108 divided by 2 would leave me with negative, that's got to be 54. And x to the 7 over x leaves me with x to the 6. And now this is a cubed root, so I'm looking for perfect cubes. So 54, is 54 a perfect cube? It's not. So what can I do? I can do the cubed root of negative 27 times 2. And x to the 6 is a perfect cube, because that would just be x squared cubed. So taking the cubed root of 27, I have negative 3. Cubed root of negative 27, I have negative 3. And the cubed root of x to the power 6 would be x squared. which means I've left over cubed root of 2. Now I decided to take the cubed root of negative 27. I guess we could have left that, we could have done it this way, which would have been, we could have split negative 54 into 27 and negative 2. But if you do that, then you're leaving a negative inside the radical, which just, it's not how we want to see our answer. If you can pull that negative out, you should. So include it with the negative 27, take the cubed root of it, and your math teachers in this course and in the rest of your life will be much happier with your answers. If you leave that negative inside the radical, you're not going to be marked fully correct for your answer.